Hello dear students, welcome back again to my channel, Physics with Mr. Ahmed. We were stopped in question 3, we did part A and part B C's left and question 452. But before to start to explain and to solve these are questions, I'm gonna I'd like to tell you some things, guys. In the previous sections we solved some examples. In section 1, page 9, guys, just the answer of part B. The answer of part B, because you have heats and colds, of course, of temperature, but the type of the physics is thermodynamic. Thermodynamic. So it's thermodynamic. So the previous video I published the video. It was written temperature. Temperature is right, but you have to write the type of the physics is thermodynamic. So just fix this. With the mistake about this part. The answer is thermodynamic, not temperature. Okay, guys. We were stopped in question 3. We did part A. Guys, part B, express this diameter in a millimeter. So now in here we have a nanometer, make it millimeter. Guys, because there is no rule or directly or immediately to convert a nanometer to millimeter, we don't have a rule like directly nanometer to millimeter. So it needs two steps actually. First, you have to convert the nanometer to. There is no rule to make a nanometer to millimeter. So first, you have to make nanometer to meter, then convert to millimeter. So because in here we have two steps, but in that question it isn't needed to do all the step again, because in the previous part, guys, in previous part we've got the answer by meter. Look. We've got the answer actually in here by meter, so we have the answer by meter, so we have to use the answer of part A. The answer, it was 10 times 10 power negative 9 meter. So look, it's by meter, so we can immediately convert to millimeter, so we can get the benefit from part A's answer. So yeah, these answers meter convert to millimeter times make a line. So again, as we said, we'll copy the unit, and in up we have to write a millimeter because the questions like asking us to cover the millimeter. Okay, guys. Yeah, and we know the rule one, and we know the rule between millimeter and meter. 1 millimeter equal 10 power negative 3 meter. Yeah, we have 1 millimeter, so write the 1 millimeter in up, and 10 power negative 3 meter next to the meter. So the meter will be cancelled, we know. So the answer equal, the down it's 1. 1 times 10 power negative 3, still 10 power negative 3. This number times 1, still the same number, 10 times 10 power negative 9. Okay, guys. Now, you'll study in math, guys. Write the 10 times, because these two numbers, they are same base, just one time at the tens, negative 9 inside the bracket, and you have to minus, and again you have negative 3. So negative with negative, it's going to be positive. So the answer is 10 times 10 power negative 6 plus 3. Look, so negative 6 with positive 3, different sign is going to be negative 3. So the answer of the power, immediately I write the answer, okay? Negative 3 by millimeter. Okay, the answer of part B's question. Okay, guys. Part C. Convert now to micrometer, guys. Again, it's really hard to use 10 nanometer to make micro. There is no rule, so again we can get the benefit from part A's question because we have meter, so we have relation between meter and micrometer, because 1 micrometer equal to 10 power negative 6 meter. Look, the relation between meter and micrometer. So again, we can get the benefit from part A's question. Yeah, part A's answer same. It was what? 10 times 10 power negative 9 meter. I would like to convert this to micrometer times micrometer. Sorry, we said you have to copy the units. If it's meter, meter, but in up micro because the question said make it micro. Yeah, the rule it was 1 micrometer equal to 10 power negative 6 meter. Yeah, I just apply the rule. The one is next to the micro, so you have to write the one in up. The other 10 power negative 6 meter down. 10 power negative 6 down. So the meter we're gonna cancel again. Make a line. Down it's 1 again, so 1 times 10 power negative 6 still 10 power negative 6. These numbers times 1 still the same number, 10 times 10 power negative 9. Okay, equal, same like the other one, write down the 10 times, again they are same base, 1 time rather 10, and negative 9 with negative 6. Between of them you have to minus, so negative with negative is gonna be positive. So the answer is 10 times 10 power negative 9 positive 6. So different sign you minus, so negative 9 plus 6, the answer is going to be negative 3. Negative 3. Negative 3 what? Micrometer. Okay. I hope to understand and to get the benefit from all the steps. If there's any question, guys, write in the comments. I'm gonna answer you, inshallah. Part C2 is done, Baba. Okay. Question 4. Question 4, 5, same. Question 4. The distance between the Sun and the Earth is about 1.5 times 10 power 11 meter. Express the distance in tetrameter. Guys, make it tetra. So easy, this one. So we have a relation immediately, directly between tetra and meter. And guys, that's why I said this table really important. Look. Tetra, tetra is equal to 1 tetra equal to 10 power 12 meter. So that's why without memorizing you cannot solve any examples. Yalla guys. Question 4. Okay. Question 4, the answer. I'm gonna write in here, okay guys? Yeah. 1.5 times 10 power 11 meter. I would like to convert the meter to tetrameter. Yalla, make times and make a line. We will say we copy the meter because the question said make a tetrameter, so the tetra should be in up. And guys, the relation, it was what the relation between tetra and meter. So 1 tetra, sorry, 1 tetrameter equal to 10 power 12 meter. Just we will apply this rule. Okay, make a line. Oh, not here. Okay. So guys, before the line, Baba, look. 1 tetra equal to 10 power 12 meters. So the meter with meter is going to be cancelled. So the down it's 1. 1 times 10 power 12 still 10 power 12. And the up times 1 still same. 1.5 times 10 power 11 equal. Write the 1.5 times and write down 1 time the base. Guys, we minus the power, the up with down, 11 minus 12. So 11 minus 12, it's negative 1. Look, the answer equal 1.5 times 10 power negative 1 by the unit tetrameter. Okay guys, question 4.2 is done and question 4 finished. Just question 5 is left. Question 5, just memorize the rule and all it's easy because just the rule and there's no idea. There's no new idea guys. Okay, last question. Question 5. The average mass of the automobile is about 1.440 times 10 power 6 gram. Express this in kilogram. This is so pretty easy. Guys, just read the rule. Believe me, there is no new anything ideas. Okay, guys, well, again, copy the numbers. 1.440 times 10 power 6 gram. I like to convert gram to kilogram. Of course, we have a relation immediately. Times make a line. Because there is a gram, again, write the grams. I would like to convert kilogram. What was the rule? Guys, as I said, kilometer, kilogram, same. Still power 10 power 3. So 1 kilo grams is equal to 10 power 3. Be careful, it's positive gram. Yalla, we have 1 kilogram, so we have to write the 1 is an up. And we have 10 power 3 grams, so the 10 power is supposed to write in the downs. So the grams are going to be cancelled. Okay, again, the down is still 1, so 1 times 10 power 3 is still 10 power 3. 10 power 3. And these numbers times 1 still is 1. 1.44 times 10 power 6 and kilograms left. Now kilograms left, yes. Okay, guys, write the numbers, don't touch the numbers, just the power. 1.440 times, because they are same base, we can simplify it. Write 1 times the 10, so 6 times 3, or sorry, 6 minus 3, guys, immediately directly do it. 6 minus 3, 3 is left. 3 what? Kilogram. So this is the answer of question 5. Guys, really this converting unit, I'm done. If there is any question, if there is any problem, if you don't understand one of the step, just send me a message or write in the comments. Inshallah, I'll be answer you all the questions, whatever you have, guys. Okay, guys, we have another topic now. It's called accuracy and precision. Accuracy and precision's important, this topic. Why not? First, let me know, understand what I mean accuracy. Accuracy is describe how to close a measured value to the true value is quantity measure. Guys, let me tell you something. Look, for example, guys, we have this subject. We have this subject, and the length of this subject, the length of this subject is equal to, for example, 3 meter. So this is the true value, or this called the original one. Original value. It's original. So this original value of measuring this distance is 3. I'm gonna I'd like to measure by myself now. Can I get the same answer like the original one or not? Again, we have the same object. We said true value or the original one is 3. I'd like to measure by myself. Is this right or no? 3 times or 2, but at least do 3 times. 3 times I would like to measure this distance. The first, I got the answer. The answer is, for example, it's 2.9. The second one, again, I'd like to do it, is 2.8. The last one is 2.7. I got 3 answers. So, guys, let me tell you what's the meaning of accuracy. I describe how close a measured value is to the true value of the quantity measured. This is the true value, but I did all this by myself. The quantity that you will measure by yourself, is it close to the original one? If it's close, it's called accuracy. For example, three results. I got 3 results. So first is 2.9. Of course, it's close. Of course, it's close to 3. So 1 point is different. The second one is 2.8. Of course, it's close. So close, like all of the numbers, so close to the 3's original one. So this is called accuracy, that like the number is accurate. But whatever, I'm gonna make the numbers now. The numbers. For example, first is 1.9. The second one, 1.6. The last one, 1.4. Look, first you have 1.4. 1.4 so far is not close to the 3. Then you have 1.9 is not close to the original one is 3. The last one is 1.6 is still not close to the 3. So far all these numbers, so it's not accurate. So in general, if the number that you will be measured by yourself, if it's so close to the original value that we have, it's called accurate. Otherwise, it's not accurate. So look, describe how close measure value is, how close the measure value to the original or the true one, like the thing that you measure, is it close to the original or no? If it's close, it's accuracy. Otherwise, no. Okay, we have another thing, it's called precision. Guys, read the definition. It's hard like to understand, but I'm gonna give you now examples. It's so good to understand. We have this example, Bob. Look, not this example. This is better. Look, or wait, this is the first one. Let me tell you the first one. Okay, which of the following that you think it's precise? Guys, we said accuracy, the thing that you measured is close to the original. Yeah, but precise, the things that I measured, I got the answer, the result. If it's close to each other, this is called precision. For example, the previous, now I showed you the number. It was 2.9 and 2.8 and 2.7. All these numbers are close to each other. So the measure, the number that you get the answer by yourself, you did. These are numbers. Is it close to each other? If it's close, yes. If it's close, we said it's precision, it's precise. Otherwise, if it's not close, so we say it's not precision. Okay, we have an example now. Which of the following that you think is precise? So we have three number. The number I should be like close together. Part A, we have 20, 20, 24, 28. No, it's not close. Part B, we have 20.1, 20.3, 20 point. Of course, so close, just different by 1 point. But don't decide. Don't say, Mister, the answer is B. Wait a minute. Part C, 30.321. So part B, part C, both of them, they are close together. So the right answer is D, because B, C, and D together, it's right, the answer. So precise, the number you have you have the result. Check the result. If the results are so close to each other, so it's called precise. Otherwise, if it's far, it's not precise. But accuracy, the number that you get, it should be close to the original value, then it's accurate. Okay, guys, so this is general accuracy and precision. We have another topic, it's called human error. Guys, now I said any of the human, or me as a teacher, you as a student, you want to measure something, like to measure the length of any object, or you are in your house, in your rooms, you want to measure the length of your rooms, the distance. Maybe during to measure the distance, the length, you will do a little mistake. When you do a mistake, of course you have got the wrong answer. So this is called human error, because it's your fault if you get any wrong answer. A human error can occur, for example, if a mistake is made in reading an instrument or recording the result. For example, we have this object. I would like to measure this. The original length is 6, but I'll do it by myself. I got 2. This is so far, so it means I did wrongly. The answer is wrong. It's my fault. So this is called human error, because I did mistake. It's my fault. It's called human. You did mistake in one of the steps, so it's called human error. So how we can avoid this? One way to avoid human error is to take a repeat measurement to certain guys. For example, the first time you did a mistake, okay, it's not like it's okay, do it at the second time. If the second time again you did a mistake, it's not worry, again the third time, like that, like repeat again to measure the distance, even it's wrong. So this is called human error. It's your fault, it's the teacher's fault, it's the student's fault if you do any wrongs get answer. Okay, so uh, the second type is called an instrumental error. Guys, an instrumental error is not my fault, it's not the teacher's fault, it's not the student's fault to get the wrong answer. No, an instrument error. Now we have an instrument error, like maybe the instrument that you will be using it's broken, or they have some things wrong, they cannot give you the correct answer, the correct result. For example, look, uh, if the balance or meter stick, guys, this is the meter stick, this picture, look, this is a meter stick. If the balance and the meter are not corrected, maybe this meter stick, maybe this one, it's not right, it's not corrected, even if you want to measure the distance. So of course you get a wrong answer. So if the balance of meter stick are not corrected, they lead to error in measurement. So measurement instrument must be chosen very carefully. It must be conditioned, guys. To measure anything, you should be careful to get the results. Or maybe, guys, do you hear this before? Like, have you heard this instrument? It's called thermometer. Thermometer is a type of the instrument they can use to measure the temperature. So, guys, the instrument is working good, but when you get the wrong answer, or no, maybe uh, the instrument sometimes they will get the wrong answer because you are a good teacher, you know how to get the answer, but maybe the instrument they have a problem or that it's broken, they cannot give you the correct answer. Otherwise, what if still you have an instrument, but this instrument is still working good, there's no problem, but you don't know how to get the answer, it's your fault. So this is called human error. But if the instrument is not working good, they give you a wrong answer, this is called instrument error, because it's instrument fault, because the reason is an instrument, that's what they give you a wrong answer. So understand, we have two type of error: instrument error and human error. Guys, so we have some factors we said in general that can affect. But before this, guy, forget to tell you this. Parallax. Guys, I have another thing. It's parameter called parallax. Parallax. It's written the definition. A difference in reading the same quantity due to looking from a different angle. Look, guys, we have three pictures. This is and this one and this one. So all of these are measuring the distance of the window. Uh, so in that case, guys, look, in part A, I would like to measure the distance in that direction. This is meter stick. I would like to measure the length of distance of this window in that direction. Part B, I would like to change my angle places, my position. Look, I did in another angle, in another direction. Part C too, it's same. So part A, part B, part C, same thing, same meter stick, same thing. We would like to get the same quantity. In all of this, we would like to get the distance of the window, but in different angle, in different position, in different directions. So this is maybe one of the factors that they can give you a wrong result. This is one of the factors, so you should be careful to get the answer, guys, in that case. So you have some factors, guys, affecting the we have some factors that can affect accuracy and precision. It's not that much important, just you can read by yourself, guys. You have another topic, it's less important, this one, it's called significant figure. Significant figure, guys, significant figure, we have this table is important, and you have some rules to get to understand what is the meaning of significant figure. Guys, look, all number in physics or in math even are significant or are countable. Except zero, we have some rules. So for example, 1732, we have 4 significant. What the meaning of 4 significant, mister? It means we have 4 numbers, like we can't count all the numbers. Look, 1 2 3 4, we have 4 numbers, so 4 significant. Any numbers in physics, you can't count it, it's countable. Except 0, we have some rules. Sometimes the 0 is countable, sometimes not countable. For example, okay guys, first rule, if the 0 is coming between the numbers, so the 0 is countable. How many? For example, 3.06. We said now all the number is countable, so 36 is countable. But how we know this 0 is countable or no? Because this 0 is coming between two numbers in the middle, of course the 0 is countable too. So the total number that you have is 3. 1, 2, 3. So first, if 0 is coming in the middle, so the 0 is countable. Second one, if 0 is coming like alone before the numbers, how? For example, 0.09. Look, from the left side, only we have a 0. So this 0 is really not countable because the 0 comes alone for the left side, so the 0 is not countable. So how many significant figure that we have in here? Just you have 9. So we have just one significant figure. Okay. The third rule, guys, if you have a number, for example 67 or 9, we have a point after, we have a number and with 0. For example 679.9110. We know, like how we know the 0 is countable or no, but before this we know all the numbers countable, we said. But how we know the 0 is countable? Guys, make it rule, if the 0 comes after the point, like it's not the 0 comes after the points, the 0 will be countable. But mister, after the point you have a number, is not important, but just after the points, if there's a 0, done, it's countable. So this 0 now, Baba, it's countable because the 0 came and after the point. So how many significant that you have? 1, 2, 3, 4, 5, 6, 7. So the total 7 significant figure. Look, another example. For example, 7.60. Again, these two numbers countable, but the 0 is countable, yes, because Mr. comes after the point. The 0 is countable. So the total number that we have, significant figure 1, 2, 3. So 3 significant figure. Okay. The last rule, one rule is left, guys. We have a number, guys. We have a number. For example, 600. How many significant in here that we have? In here, just you have one significant. Why? This 0 is not countable. Why, mister? But you said after the if there is like it's just 0 is countable. No, I didn't say that. I said if you have a point, but in here there is no point. Alone after the number just you have a 0, so this 0 is not countable. So in here just you have 6, so you have one significant figure. Guys, let me bring two questions in different step, different technique. 6.70 and 670. Just different totally, just by points. All the questions gonna be different, Baba, because the number is countable. This 0 is countable, yes, because it comes after the point. So the total is 3. So this 0 is countable, no, because there is no point. Just you have two numbers countable, it's 2. Look. Okay, guys. So in general, all numbers are countable. Look, all numbers except 0. Except 0, we have some rules. We have some rules except rule number 1, rule number 2, rule number 3, rule number 4. Understand and memorize is important, yeah, because you have example in the sections chapter. That's why, guys, important. Okay. Guys, today's enough, and I'm done. If there's any question, inshallah, from the upcoming videos, upcoming sections, we'll study this page, rules rounding, and we'll study some example that here is left. I'm done, guys. Have a nice day, and if there is any question you can write down in the comments. Thank you so much. Thank you for all.